friends, welcome to my this new YouTube video. Today we will discuss about residential building analysis and design. For that we will use Etabs 2016. This is the AutoCAD plan of residential building, G+1 story building. First of all, open the Etabs 2016. Click on new model. Click on use built-in setting unit. Metric SI. Display unit is metric SI. Steel section database Indian. Steel design code IS 800 2007. Concrete design code IS 456 2000. Click OK. Uniform grid spacing. Number of grid lines in X direction is 4. Number of grid lines in Y direction is 4. Spacing of grid lines in X direction is 4 meter. Spacing of grid lines in Y direction is 3 meter. See here in plan view, spacing of grid lines in 4 meter. There is a 4 grid lines in X direction, 1, 2, 3, 4. And in Y direction spacing is 3 meter, 3 meter, 2.8 meter. And grid lines is 1, 2, 3 and 4. So we are doing here number of grid lines 4 in X direction, number of grid lines 4 in Y direction, spacing 4 meter in X direction and spacing 3 meter in Y direction. Click on custom grid spacing. Click on edit grid data. In X direction, click on display grid data as spacing. So 4 meter in X direction spacing. In Y direction, first grid line is 2.8 meter spacing. Second grid ID is 3 meter spacing and third is 3 meter spacing. Click OK. Simple story data. Number of story is G+1 plus terrace floor 3 story and other 2 story is water tank level. So 5 story. Typical story height is 3 meter. Bottom story height is 1.5 meter. Custom story data. Edit story data. Changes to footing. Story 1 is ground floor. Second story is first floor. This is terrace. This is water tank bottom level. This is water tank top level. Ground floor is at 1.5 meter height. First floor is 3 meter height. Terrace is also 3 meter height. Water tank bottom level is 2.6 meter height. Water tank top level 1.5 meter. Click OK. Select grid only. Click OK. So our model is ready. This is plan view and this is 3D view. Now define the material property. Go to material property, add new material. Region is India. Material type is concrete. Standard is Indian. Grade is M30. Make it M20. Click OK. So M20 material property is displaying. Click on OK. Add new material property. Indian. Rebar. Indian HYSD 415. Click OK. So this is HYSD 415 property is displaying. Click OK. delete material, this will be as it is. So we will define M20 and HYSD 415 material. Click OK. Now define the section property. Click section properties, frame section. Delete multiple properties because we are giving new property section. So delete this. OK. Add new property. Click on add new property. Section shape is concrete rectangular. Select concrete rectangular section. Give property name is beam 230 by 350 mm. Give material type is M20. Give section dimension, depth is 350 mm, width is 230 mm. Modify or show rebar. Select M3 design only beam section. Longitudinal bar is HYSD 415. Confinement bar is HYSD 415. Top bar cover is 30 mm. Bottom bar cover is of 30 mm. Click OK. Click OK. Add new property. Selection shape concrete rectangular. Select concrete type rectangular shape. Property name is C column 230 by 350 mm. Material is M20 mm. Section dimension is 350. Width is 230. Modifier sorry bar. This time PM3 M3 design column section selection. Longitudinal bar HYSD 415. Confinement is also HYSD 415. Clear cover 40 mm. Number of longitudinal bar 3. Number of longitudinal bar in other direction is also 3. Longitudinal bar size 12 mm. Corner bar size also 12 mm. Confinement bar is 8 mm. Click OK. Click OK. So we are defining the beam section 230 by 350 mm, column section 230 by 350 mm. This section is deleted. Click OK. Now define slab section. Click on define section property. Slab section. Go to add new property. Give name S115 mm. Slab material M20. Modeling type cell thin. Property type is slab. Thickness is 115 mm. Click OK. Add new property. This is one-way slab. One-way slab 115 mm. Slab material is M20. Modeling type is membrane. Use special one-way load distribution. Type slab. This is what cancel. Type is slab. Thickness is 115 mm. This is one-way slab defining. Click OK. Delete other property. Staircase slab is add new property. Staircase, which is 150 mm. Slab material is M20. Types of slab thickness is 150 mm. Click OK. So 3 types of slab is defining. Click OK. Now assigning beam. For the click on quick drop beams. Properties 230 by 350 mm. Now this is 1 story. By clicking on arrow, go to ground floor 1.5 meter level. We are assigning beam on 1.5 meter level, ground floor level. Moment release is continuous. Properties B230 by 350 mm. Select whole model at ground floor level. So ground floor level beam is assigning. Go to first floor level. Drag mouse to whole model. First floor level beam is assigning. This is on terrace floor level. Terrace floor level beam is assigning. This is water tank level. This is water tank level beam is assigning. This is water tank top level. This is also beam is assigning. Now for distribution, now for secondary beam, go to first floor. Here secondary beam at 2 meter distance is created. So property name is B230 by 350 mm. Moment release is pin. Plan of offset is 200 mm. Drawn beam 230 mm by 350 mm. Moment release is pin. Offset distance 2000 mm. Parallel to Y dimension. So this is secondary beam is created. Now here at 1.2 meter distance, one secondary beam is created. See, this is secondary beam at 1.2 meter distance. So draw beam command is used. Use property 230 by 350. Moment release pin. Plan offset 1200 mm. Line to end up straight line. Drawing content type parallel to X. Road secondary beam. This beam is deleted. Now replicate it on first floor and terrace floor. So select two distribution. These two secondary beam distributed. Go to edit, replicate, story on first floor and terrace floor. Click apply. Okay. So on first floor and terrace floor also secondary beam is assigning. Delete this beam on first floor and terrace floor. Now assigning slab section. Here is a staircase. And this is 0 meter level. There is no slab. On ground floor level, we will use this slab. On ground floor level, there is also no slab. On first floor level, this slab is there. So quick draw slab. Select S115 slab. 1, 2, 3, 4, 5, 6, 7, delete this slab and this slab. Now give slab here. And this slab. This slab. This is one way slab. So one way slab. This is staircase. Now select all slab. Replicate in on terrace level. So go to edit, replicate on terrace level. Apply. Okay. So this is terrace level slab. Now is water tank level slab. Quick draw slab. This is one way slab. We have to go two way slab. So click on quick draw slab. Make it two way slab S115. Select. Go to water tank top level. Select. So slab is defining. Now this is 0 meter level. This is first floor level. Now we have to assign the column section. So click on quick draw column. Click on column section. Drag mouse and select the all model. So column is created from footing level to ground floor level. On first floor level, ground floor to first floor level also all column is created. Terrace level is also all column is created. This is water tank bottom level. Here is also all column is selected. This is here also all column is created. Now for column orientation, suppose these two column is oriented, so select the to this column. First of all, delete this column and delete this column. For orientation of this column, go to quick draw column. Column property of object is displaying. Give column number name is C230 by 350 mm. Moment release is continuous. Angle degree is 90 degree. Plan offset is 0, 0. So this is 90 degree angle. Two column is created. Now for coincide the edge of the column with beam, we have to give offset also. We can give offset of the column, so we can coincide the edge of the column with the edge of the beam. For that, first of all, delete that column Suppose this two column has to be coincide with the beam edge. So select quick draw column. Property name 233 50 mm. Moment L is 0. Angle degree 0 degree. Plan offset in x direction. So this is 350 mm column. So 175 mm of half minus 115 mm. So 60 mm. 60 mm is plan offset. We have so here 60 mm offset distance. We have to create two columns. Similarly, this two column can also offset, but this is in minus x direction. So we have to create just two column at minus x direction. Click quick draw column. Select property C 233 mm. Moment release continuous. Plan offset is minus 60. Select column, delete. Go to click draw column 3 to 350 minus 60. Now this two column has to be oriented in y direction. So we can make it delete. Go to click quick draw column command C230 by 350 mm. Command is continuous. This time angle is 90 degree. This is 0. So this two column is rotated by 90 degrees. In this way we can offset the column and create column at whatever distance offset we have to make. Click save. G+1 story building. Click save. See, G+1 story building already exists. Do you want to replace it? Click yes to replace it. Now staircase we have to define. For that go for first floor. Now go for first floor. Select whatever changes you're doing, replicate. First floor, terrace floor. Apply. Okay. Select this. Edit, replicate. Story. First floor, terrace floor. Apply. Okay. Select this. edit, replicate, story, first floor, terrace floor. Similarly, these two. Edit, replicate, story, first floor, terrace floor. These two also. Edit, replicate, story, first floor, terrace floor. Apply. Okay. Now see, not changing. Delete, 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 undo, undo, undo. In this way we can change the orientation and option distance of the column. For this project we cannot change the orientation offset, but if you want to change you can do it in this way. So do it yourself. Make it 0, column 230 by 350. Click on save. Now we have created a staircase. This is a ground floor level. Replicate beam in x direction. Dx distance this time 1 minus 1 meter. Apply. Okay. So this is beam is created. Actually there is no beam, but after creating slab staircase we will delete the beam. Now divide this beam, edit frame, divide frame, divide to point. Okay. So these two beam is deleted. This beam is divided in two beam. Now this is at middle height, middle landing level is also there. So first we have to make it 3D plan. Create slab here, staircase slab 150 mm. So one slab is created. Now we are at mid landing. For that we have to divide this column, these two columns, for creating the mid landing. So for that we have to select first this two column, click on edit frame, divide into two frame object, click apply. Okay, so these two in two part divided, click beam. Now you have to create beam here at mid level. So this is beam is created. Now replicate it, this beam, edit, replicate, this time 1 meter, because this is 1 meter width of landing, so 1 meter, apply. Okay, this is created. This is also divided in two part, so edit frame, divide frames in two part, apply. Okay, so this is in two part divided. And drawing slab ST 150 mm from here to here, and here, here, click OK. So this is one flight is created for landing level, landing slab. Click enter. So landing slab is created. Now replicate it. In first floor level. So edit, replicate, story, first floor, apply. Okay, so this is created in first floor level. Draw slab from here to here, here, here. Click enter. So ground floor first floor level slab is created. Now this beam has to be deleted. Delete, 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 delete. Here is also deleted. Delete. So select slab and replicate is on first floor. And terrace floor. Okay. So up to terrace level, we will defining the staircase. Here we have to one beam has to be defining. At mid landing level. Click enter. Now we have to give the load for all the model, for all model. So first of all, we have to give a slab load at first floor and terrace floor level, and water tank bottom and top level. At the first floor level, slab. So there is a floor finish of 1 kilonewton per meter square and live load of 2 kilonewton per meter square for all rooms. For cantilever slab, now we have to lap cantilever. So we have to give a cantilever slab at first floor level. Suppose we have to give cantilever here. So draw joint objects, select this, and offset x meter, 2 meter, minus 2 meter, minus 2000 mm. Click enter. So here one object is created. Similarly here is also one object is created. Now draw the slab, cantilever slab. Click enter. So cantilever slab is entered. For cantilever beam from here to here, draw beam B230 by 350 mm. This is continuous. Click undo. Again click slab. This is S115. Click enter. Now for beam B230 by 350 mm is continuous. Draw straight line. This is also draw beam 230 by pm continuous. So beam is assigning. This is cantilever beam. This joint is assign joint, restrain, 3, apply. Okay, so this is free joint. Now click save. For a fixed joint at foundation level, go to 1 story, Make it plan view, putting, applying, okay. Select all joint. Go to assign, joint, restraint, fix support, apply, okay. So fix support is assigned to all model for all columns. Now give load. For that, define load patterns. This is dead load and live load. Now we have to give earthquake load in X direction. This is seismic load. This is IS 1893 2000. Add new load. Now earthquake load in Y direction. Seismic load IS 1890. Click add. Now wind load in X direction. This is wind type. This is IS 875 2015. Add new load. Wind load in Y direction. Wind load IS 875. Add new. Now earthquake in X direction. Modify lateral loads. For X direction load. Untick all this and only tick X direction. Now seismic zone factor for Surat. So here for seismic zone of Surat region, this is momentization RCC from building with brick infill panel and RC building with special moment existing chain. So seismic zone is 3, zone factor is 0.16, importance factor 1.2, and response reduction factor 5. So seismic zone is 3, zone factor 0.16. Soil site type is two. Medium steep soil type. Soil type is 2. Medium soil type. Importance factor. Importance factor is 1.2. Response reduction factor is 5. 1.2. Response reduction factor is 5. Bottom story footing to water tank top. Time period is program calculator. Click OK. Similarly, in earthquake Y direction, modify lateral load. Tick mark only Y direction. Seismic zone factor is 0.16. Soil type is type 2. Impedance factor is 1.2. Response reduction factor 2. Time period is program calculator. Click OK. Now wind load in X direction. Modify lateral load. Wind speed. For Surat region, category 3 average height of numerous objects surrounding this structure is up to 10 meter and topography is plain time of wind slope less than 3 degree. Basic wind speed is 44 meter per second. So wind speed is 44 meter per second. Terrain category is 3. Building category 3. Importance factor 1. Risk coefficient K1 K3. Importance factor. K1 is 1.07. Topography K3. K3 is 1. Importance factor is 1. This is design life of structure is 100. If all general buildings and structure, then K1 is 3, K3 is 3. And importance factor is 1. Wind coefficient structural class B. Click OK. Modifier show. This is 0. Click OK. Click OK. For Y direction, go to modify or lateral load. Do it 44 meter per second. Terrain category 3. Building terrain category is 3. Importance factor 1. Risk coefficient 1. Topography is 1. Click on modify or show. 90°. Click OK. This is 0.86. Windward coefficient. Windward coefficient. This is 1.22. 0.86. Click OK. So we are defining earthquake load in X, earthquake load in Y, wind load in X, and wind load in Y. This is dead load and live load. In Etabs, dead load is auto-generated, so we have not to give dead load for beam and column section. We have to give live load and floor finish load. So first of all, go to first floor, select all rooms. Now assign frame loads, cell load, uniform. This is dead load, 1 kN/meter square floor finish. Add to existing load, apply. Okay. On terrace floor, also select on slab, assign frame load, cell load, uniform, dead load, 1 kN/meter square. Click OK. On water tank bottom level, suppose give dead load, floor finish load, cell load, uniform. Dead load is 1.5 kN/meter square. Apply. Okay. On top level also, we say load uniform. Dead load 1.5. Apply. So select the object. Apply. Okay. On terrace floor, floor finish is 1.5 meter. So change it to 1.5 meter. On terrace level, select all. First of all, delete the cell load, uniform load, delete existing load, apply, deleted. Now add to existing load 1.5 meter, apply. Go to previous selection, 1.5 meter, apply. Okay. Now give live load. Here is also 1 meter, 1 kN/meter square. So here is also we have to give assign cell load, uniform load, 1 kN/meter. Okay. Select, assign cell load, uniform load, dead load, apply. Okay. Now deleted here, assign cell load, uniform, delete, apply. Now existing info, apply. Okay. Now we can see here load, dead load, apply. On terrace level also, here is 1.5 meter square. So assigning shell load uniform 1.5 meter square to existing apply. Okay. Now first floor live load. Live load is 2 kg per meter square. Assign shell load uniform. Make it live load 2 kg meter square. Add to existing. Apply. In passage is 3 kg per meter square. Assign shell load uniform live load 3 kg per meter square. On terrace level, there is a 2 kg per assign shell load uniform. On terrace level 1.5 kg meter square live load to existing. Okay. Here is also 1.5 kg meter square. Assign shell load uniform 1.5. Okay. Now on staircase, floor finish is 1 kg square and step is 2.06 kg square and live load is 3 kg square. Live load is 3 kg square. Floor finish is 1 kg square. Step is 2.34 kg square. Floor finish is 1.75 kg square on inclined slab. So go to 3D plan. Select this, 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 this. And this. For that, assigning shell load uniform. Dead load is 1 kg square and live load is 3 kg square. Apply. Go to create selection 3 kg square. Click OK. So we are defining 3, 3, 3, 3. And floor finish is 1 kg per meter square assigning. Similarly on inclined slab, select inclined slab. So inclined slab is selected. Assigning shell load uniform. Inclined slab load is 1.75 floor finish and 2.34 floor finish. So 1.75 plus 2.34. 0.09 dead load. Apply. Go to previous selection. Live load. Assign shell load. Uniform load. Live load. Add to existing load. Live load is 3 kg per meter square. So live load is 3 kg meter square. Apply. Okay. Now live load is live load. Now for live load reduction, for seismic loading, go to define mass source MS SRC1, modify or show mass source, click on specify load button, untick all this. Dead load is 1 multiplier, add, and live load. We are giving live load 2 kg square, which is less than 3 kg square. So multiplier is 25%. So 0.25 multiplier. Click add, include lateral mass, lump lateral mass. Click OK. Click OK. Here MS SRC default mass source. Click OK. Now we have to analyze the model. First of all, save the model. Now for analyze the model, check the model, give the diaphragm. So define my diaphragm, define section property, assign frame, assign joint, diaphragm D1, apply to all story, apply. First of all, select all model. So all model is selected. Assign joint, diaphragm D1, apply. So in all model, diaphragm is defining, assigning. Now analyze. For that, check model, select all, joint story also, length tolerance for checks 1 mm, click OK. So model is checked. There is a Warner horizontal rigid diaphragm connection found between joints at different elevation. Please check. OK. No warning message were generated. OK. Now analyze. Run analysis. Warning, horizontal rigid diaphragm connection found between joints at different elevation. Please check. OK. So analysis is done. This is deform shape. Start animation. So this is deform shape. Stop the animation. Tick mark on show undeformed shape. So this is undeformed shape. Now this is plan view. We have to make it plan. Ground floor. Apply. Okay. Now we have to define the load combination. At default design combination. Concrete frame design. Convert to user combination. Editable. Click OK. Click on convert. Click OK. So this is all design combination. By double clicking on it, we can see the design combination. Dead load. Okay. Dead load, light load. Okay. 0.9. Okay. Point 9, 1.5. Okay. 1.2. 1.2, 1.2. So this is all load combinations. Click OK. Now run analysis. So unlock the model. Okay. Analyze. Run analysis. Warning: original diagram connection found. Even joints are different elevation. Please check. Okay. So this is undeformed shape. Click start animation. So this is stop. Click on show undeformed shape. Now we can display the story response plots. So this is story response plot. So maximum displacement is 0.562968 mm. Zero point 562968 meter. Maximum displacement is 0.56 and our limit is 0.004 times height. So story height is 11.6 meter. So 11.6 into 0.004 0.0464 meter. 0.0464. There is a limit of 0.56. .4 meter, 4 mm. In this way we can check the limit, that it is in limit, that maximum limit is in under maximum limit or not under maximum limit. So we can check it. We can design the building by concrete frame design. View revised preferences. This is preference wise 456 2000 step by step. So check it. Just click OK. Now design concrete frame design. Rebar selection rules for column. For column, smallest bar size is 12 mm. Largest bar size longitudinal is 25 mm. 25 mm. Smallest bar size for ties is 8 mm. Largest bar size is 10 mm. Minimum spacing is 50 and maximum spacing is 300 mm. For seismic is also smallest bar size is 12 mm. Largest bar size is 25 mm. Smallest bar size is 8 mm. Largest bar size is 10 mm. Minimum spacing 50 and maximum spacing is 300 mm. Click OK. Now for concrete frame design, reverse section rules for beams. For beams also, longitudinal bar, smallest bar size is 12 mm. Largest bar size is 20 mm. Bottom rebar is per mm 12 mm. Largest bar size is 20 mm. Preferred bar size is 16 mm. Preferred bar size is 16 mm. Minimum number of bars 2 at top. Minimum number of bars 2 at bottom. Stirrups. Smallest stirrup bar size is 8 mm. Largest is 10 mm. Minimum spacing 75 mm. Maximum spacing is 300 mm. For seismic requirement, longitudinal smallest bar size is also 12 mm. For bottom bar also 12 mm. Largest bar size is 20 mm for top rebar and 20 mm for bottom rebar. Preferred bar size is 16 mm for top and 16 mm for bottom. Minimum number of bars 2 for top rebar, number of bars 2 for bottom rebar. Now for seismic requirements, stirrups bar. Smallest bar size is also 8 mm. Largest bar size is 10 mm. Minimum spacing 75 mm. Maximum spacing is 300 mm. Click OK. Now design concrete design frame design. Start design check. Start design or check. So this is check the design requirement. So this is the longitudinal bar reinforcement area, which we can see here for 3D plan also. So this is all reinforcement area in beam and column section. In this way we can design the column and beam. Now display. Now for detailing, now you can see the concrete frame design, display design info. So design input is longitudinal reinforcement. You can also see the percentage of the rebar. This is the percentage. So this is percentage of the reinforcement area. You can see shear reinforcement also. This is shear reinforcement area. for beam and column section. In this way you can see beam column capacity ratio, column beam capacity ratio, general reinforcement details, for detailing, go to detailing, concrete component preference, detailing preference, steel component preference, go to start detailing. So this is detailing is done here. You can see the detailing by here, loads, load pattern. This is design, this is analysis, this is results, this is load cases, this is load combination. So this is load combination. Old load combination we can see here. This is all results. So you can see the frame results, beam forces. So you can see here all data, design data, load combination, station, forces, shear force, torsions, moments of every beam and column. Similarly in design also, concrete design, design forces, beam design forces. This is beam design forces which is used here. At every level and all beams. Similarly, for column design also, you can see column design forces which uses here for designing. Shear force, torsion, moment, and load combination which is used. This is concrete column. So now report is created. For that, go to reports, summary reports. This is all summary reports. So this is the report which we can see here. Thank you for watching this video. If you like this video, please like it, subscribe it, and make a bell icon so we can, when we can make other videos, you can see it easily. Thank you for watching. Thank you.